Hi, good morning, class. I'm so sorry that I couldn't be there with you today. I am not feeling well, so I'm bringing you this lesson from home. So before we get started, I do want to announce that you guys have a quiz on Friday. Your quiz is going to include everything that we've learned so far about congruency in triangles. So that does include proofs. And it's also going to include what we learned about circumcenter yesterday and what we're going to be learning about incenter today. So please make sure you review your notes, you study. You do have a packet on proofs that we went over on Monday, and you have all of your notes. So please make sure that you are studying for that quiz on Friday. We will review briefly before the quiz, but I do need you guys to study. Okay. So for today, we are focusing on incenter. So the incenter of a triangle is the point where all of the angle bisectors come together in a triangle. So when I have a triangle, let me draw you guys a triangle so I can show you what I'm talking about. Let me try that again. Okay. So when we have angle bisectors, when they all come together, it forms an incenter. So if I have this angle, actually let me go back and label these. So this is angle A, B, C. When I have an angle bisector, that means that an angle, so let's say angle A, is getting bisected. So that means that I am drawing a line. Let me make a better line. Go back. I am drawing a line that goes straight through the middle of the angle, which means that this angle is congruent to that angle. When I do the same thing to the other angles, there's going to be a point where they all come together. So this angle will be congruent to that angle. And then same thing with angle C. I make an angle bisector, which means that this angle is congruent to this other angle. Okay. This point where they all come together, right here, that red point is the incenter. Okay. So from the incenter, that point there is the same distance away from each of the sides, on all sides. So the incenter is the same distance away from AB than it is to BC than it is to AC. And remember what I mean by distance, and let me change the color here, is that I'm going from that point, the incenter, and I am making a line that's perpendicular to the side, okay? That perpendicular line is going to be the same distance than the distance from the incenter to line AC. Okay, so these two perpendicular lines are congruent. The other lines are not. Okay, so like my pink line and my orange line and my green line, those are not congruent to each other, and none of their parts are congruent to each other. Okay, the only ones that are congruent are the light blue lines that I'm drawing right now. And from the incenter, I can also make a distance between the incenter, that red dot, and line BC. So that one's going to be pretty lined up too. that pink line, but it's a little off to the side. So that distance is also congruent. Okay, so the incenter is making a point, or the angle bisectors are making a point called the incenter. That is the same distance away from all of the sides. Okay, so you can use that information to work on problems that you're going to get. Okay, so for example, let me go on to a different part. Questions that you're going to be getting are something like this. You might be getting a question where they're telling you, actually, let me label this. We'll label this point D, this point, and then we'll label this point E, and we will label this point F, and we will label our incenter as I. Okay. So if the question gives you something like DI is equal to 14, and they're asking you what is the distance of EI. Well, we just learned that DI is a distance from the incenter, and EI is also a distance from the incenter to the sides. So that means that DI and EI are congruent to each other. They are also congruent to FI. Okay, so all of those segments are congruent to each other because those are distances from the incenter. Okay, so if they're telling me that DI is 14, that also means that EI is 14. Okay. Other questions that you're going to get are going to have to do with the other sides. Okay, and something that I want to point out. So you have that this angle over here, which I'm highlighting, is congruent to this other angle, which I'm going to highlight in a different color, to that angle, right? Those two angles are congruent to each other. And then we have, actually, let me go back. It's highlighted in the same color. We have that these two angles are congruent to each other. We also have that this angle right here is congruent to this angle over here because those are right angles, and right angles are always congruent to each other. And then we have that this side is being shared by these two triangles, which let me highlight that in a different color. So we have this triangle here, and we have this triangle here, right? And because they share angles, they share two angles that are the same and a side, these two triangles are congruent to each other. Okay, so the blue triangle, which let me color the rest of it in, and the purple triangle, those two triangles are congruent to each other. So if I were to be given that AD is equal to 11, then that means that AF is also equal to 11. Okay. Another thing that I want to point out, and that's going to be the case with all of the rest of the triangles that are made. So let me change colors here. This pink triangle is congruent to this yellow triangle over here. And this green triangle is congruent to this orange triangle over here. Okay. Something else that I want to point out is that all of these triangles that I've colored in, those are all right triangles. Because they're all right triangles, if they give you some information, for example, let's say that they say that CE, this line, CE, let's say they tell you that this is 12. Okay. And then they tell you that IF, this line over here, let me change colors. This line right here, they tell you that IF is 5. And they want you to find segment IC. All right. Well, right now I have segments in different parts, right? But if I use the fact that the green triangle and the orange triangle are congruent to each other, I can actually complete a triangle. So this side over here, FC, is also 12, right? So now I have that side FI is 5 and side FC is 12. And I'm trying to find side IC. I have a right triangle. If you guys look at this, there's a right angle right there. I have a right triangle. So that means that to find IC, so I'm trying to figure out what IC is, right? I can use the Pythagorean theorem. I can use a squared plus b squared is equal to c squared. IC will be my c squared. So I'm going to have 5 squared plus 12 squared is equal to c squared. So then I just do that math and I figure it out, okay? So I'm not going to do all the math on here, but trust me when I say c is going to be equal to 13. Okay, you guys can check that out in your calculators later, okay? So then I can find the length of CI, or IC. So that means that IC is equal to 13, okay? And that would be my answer there, okay? Those are the types of problems that you guys are going to get with angle bisectors. Another thing that you're going to get is kind of simple, almost forgot. So I mentioned that the incenter is made by angle bisectors, so that means that the angles are always equal to each other. So if you get a problem where they tell you something like this, they tell you that angle, let me see what the angle is. Angle ECI is equal to, 3x plus 15. And then they tell you that angle FCI is equal to 5x minus 10, okay? All you have to do there is, since ECI and FCI, if we look at this over here, those two angles are congruent to each other. So then that means that I can just set these congruent or equal to each other, right? So I can just say that 5x minus 10 is equal to 3x plus 15. And then I just solve for x and I can find the angle of each one by plugging it back into either one of these expressions, okay? All right, so that's everything for today. You guys have worksheets that you're going to be working on. You do have a worksheet where we're going to go back and practice what we learned yesterday with the circumcenter. So make sure that you're going back to your notes on that. I just wanted to give you guys a little bit more practice on that. And the other worksheet is just on angle bisectors and the incenter. Okay. I hope to see you all tomorrow and have a great day. Bye.